Assalamu alaikum students. Let us do some examples on binomial distribution. In these examples we will calculate probability on the probability distributions. Okay, this example states that let us consider the probability of non-complying products in a manufacturing process is 0.5. Use cumulative binomial table for n is equal to 5 to calculate the probabilities for finding exactly 3 non-conforming products and 3 or more non-conforming products. Okay, so this process it is already mentioned that we have to use cumulative binomial table, means that this one it follows binomial distribution. Okay, that the probability of finding non-complying products is 0.5 in that binomial probability distribution. But now we are told to find out the probability of finding exactly 3 non-conforming products in a sample of n is equal to 5. So means that we have a sample of 5, and what is the probability that out of those 5 we will find 3 non-conforming products? Or the second part, if we have a sample of 5, what is the probability that we will find 3 or more than 3 non-conforming products? Okay, so we have to find both of these probabilities. But first we need to familiarize ourselves with the cumulative binomial table. You know that binomial distribution has two parameters, one is n and one is p. So these values on this row, the top one, these values are for p and for only the sample which is n is equal to 5. Okay, means that in this is a sample which has 5 observation or 5 products, or 5 products in this sample. Okay, so we are using this table. So actually, remember that we will have different tables for different values of n. Okay, so this is the value of n and these are the values of p's. We are already given the value of p is equal to 0.5. so this is the value, this is the column that we are interested in. All others are irrelevant for us. Okay, so this one is the one that we are interested in. Okay, and this one, the first column k, or we can also call it x. So this one represent this thing. So the actual thing that we are interested in, the number of non-conforming products. Okay, so this represent that number, that if 0 means 0 non-conforming product, 1 means 1 non-conforming product, 2 means 2 non-conforming product, and 3 means 3 non-conforming products, and so on. And this area here, this white area carries the probabilities. Okay, for example, for 0 and 0.01, the probability of finding 0 non-conforming products is this is the probability, and the probability of finding 1 non-conforming product for p is equal to 0.1 is this one, and the probability of finding 2 non-conforming product with the p value of 0.5 is this one. But this is not exactly this one, so because this is a cumulative, so actually this value, for example 1, it represents the probability of finding 2 or less than 2. Okay, so from 0 until 2 non-conforming products here. And for example, if 3, this value, it represents all the probabilities of finding the non-conforming products less than or equal to 3. Now if we are, it is already mentioned that the value of p is 0.5, means that we have to consider this column only, and there is 3. So we start with this and go downwards. So the first one is 0. 0 means that 0 non-conforming product with p is equal to 0.5. so this one states the probability of finding exactly 0 non-conforming products, okay, in that sample of 5. and the second one, which relates with 1 here, it's this one actually represents the probability of finding 1 or less than 1 non-conforming products. Okay, means less than or equal to 1 non-conforming products at p is equal to 0.5, and this one, which corresponds to 2, it represents the probability of finding 2 or less number of conforming products. Okay, or you can say less than or equal to 2 number of products, number of non-conforming products. Okay, so on until here. So this one represents 5 or less than, the probability of finding 5 or less than 5 non-conforming products. Okay, so if we want to find out exactly 3, we will go to 3, but this is not for 3, this is for less than or equal to 3, means that it carries all the probabilities below it also: the probability of finding 0, the probability of finding 1, the probability of finding 2, and the probability of finding 3. So this one accumulates all the probabilities of finding 3 or less than 3 non-conforming products. Then how can we find the probability of exactly 3 non-conforming products? Okay, this is very easy. So what we do is, because this one includes all the probabilities of finding 3 or less than 3 non-conforming products, so we simply subtract these values or just this value from this, and we find the probability of finding exactly 3 non-conforming products. Okay, do you understand? This one carries these two. Okay, let me repeat it now. So this one carries this, this one carries these two, this one carries this, and this also. Okay, so this one carries all the probabilities of finding 3 or less than 3. This one carries the probability of 2 and less than 2. This one 1 and less than 1, and this one just a 0. So this one, if 0, then we do not need to subtract anything, just this one. So this one is the one that we are interested in, and we want to find out exactly 3. Exactly 3 means that, sorry, this one. So in exactly 3, we can simply subtract this value from this value, because this includes probability of finding 0 plus probability of finding 1 plus probability of finding 2 plus probability of finding 3, right? So, and this one, it carries the probability of finding 0, the probability of finding 1, and the probability of finding 2. Okay, so if we subtract this one from this one, we are already eliminating the probability of finding 0, of 1, and of 2, and we will be left with only the probability of finding exactly 3 non-conforming products. Now let us see how we do it. So according to the table, the probability of finding 3 or less than 3 is equal to probability of finding 0 products, probability of finding 1 product, probability of finding 2, and probability of finding 3 products which are non-conforming. Okay, this means the accumulative probability. Okay, so this one is from x less than or equal to 3. Less than these 1, 2, and 3, these are less than 3, and this is equal to 3. Now if we subtract these ones from this, we will get this one, right? Very simple mathematically. But these 3 can be represented like this, that the probability of finding less than or equal to 2 is equal to probability of finding 0 plus 1 plus probability of finding 2. This is accumulative probability for this thing, x less than or equal to 2. Now if we can replace this value here, we can write it like this, right? So instead of this, we replace them with probability of finding less than or equal to 2 non-conforming products. So simply we can replace these 3 with this thing here. Because we cannot find exactly these values from the table, we can find these values from the table only. Okay, that is why we have to do this procedure. Now we can write it like this also, right? So this is cumulative probability, this is cumulative probability, this is not. Okay, so we will keep it here, x is exactly equal to 3, and send it to the other side, and we get this value. Okay, so these two on the other side and this on this side, so means that p x less than or equal to 3 minus p x less than or equal to 2. Now we can go back to the table and see the value for x is equal to, or x is less than or equal to 3, and probability of x less than or equal to 2 in the column of p is equal to 0.5. We note that value, we note these values, and we insert here. So the probability for x is equal to less than or equal to 3 was 0.663, and for this was 0.317. We subtract, and this is our probability of finding x or exactly 3 non-conforming products, which is 0.346, right, or around 0.35. Now let us do the second part. I hope you understand this one. The second one, let's do the second part. Second part is, we can again write it in this form. So this one is the probability of finding 3 or more. So 3 or more means that 3 plus 4 plus 5, because 5 is the end. We have only 5 samples, or only 5 observations in the samples, or 5 products in the sample. So probability of finding 3, 4 or 5 means that 3 or more, right? Okay, now this is a bit tricky, because the table gives us value for less than or equal to 3, right? It doesn't give us the value for greater than or equal to 3, right? So for that we have to know what is the total probability, and then we subtract the rest from it. So the total probability, as you know, is, or the maximum probability is 1, right? So if we subtract the probability of finding probability of finding x less than 3, and we subtract it from 1, we will be left with the probability of finding more than or equal to 3 probability, right? Do you understand it? We can write it like this. So this is the maximum probability, and from it, if we subtract the probability of finding less than 3 non-conforming products, we will be left with the probability of finding equal to or more than 3, right? Okay, so here now we can write this value here, but we do not know the value of x is less than 3. The probabilities that are given in the table, those are for x less than or equal to 3. So what are we going to do? So what is less than 3? Less than 3 is what? 2, right? So the probabilities for x less than 3 is equal to the probabilities of finding non-conforming products less than or equal to 2. So x is less than 3 means x less than or equal to 2. So we can write it like this. So because it is until 2 and after 2 is 3, so x less than 3 means x less than or equal to 2, and this is binomial distribution, so there are no numbers between 2 and 3. Okay, so now we get the value of x less than or equal to 2 from the table, and we insert it here. That was 0.317, so we subtract 1 from 0.317 and we get our answer. This is 0.683. so the probability of finding equal to or more than 3 non-conforming products is 0.683. so the probability of finding exactly 3 is 0.346, and for finding more than or equal to or 3 products which are non-conforming is 0.683. Okay, in our example number 2, a producer of soft drinks was certain that her brand had 10% share of the soft drink market. In a market survey involving 2,500 consumers of soft drinks, X is equal to 211 expressed a preference for her brand. If the 10% figure is correct, calculate the probability of observing 211 or fewer consumers who prefer her brand of soft drink. Okay, in this one, this also follows the binomial probability distribution. So here we are told that a producer of soft drinks has claim that she has a 10% share of the soft drink market. So in order to test that claim, a survey was performed on 2,500 consumers. So we have a sample of size 2,500. Okay, n is equal to 2,500 to 2,500. So out of these 2,500, 211 people prefer her brand of the soft drink. Okay, so they say that they like this brand over other brands. Okay, now if the claim that 10% the figure is correct, her claim is correct, we have to calculate the probability of observing this thing or fewer consumers who prefer the soft drink brand. So here the value, this 10% is equal to, it means if you want to represent in other ways in a decimal point instead of percentage, we will write it as 0.1, right? So P is equal to 0.1, N is equal to 2,500, and X is equal to 211. Now we have to find the probability of observing less than or equal to 211. Okay, so here we are going to use, we are not going to use the table because table for 2,500 it will be too large. So we are going to use the p value method. So here n is equal to 2,500 and p is equal to 0.1 as we just saw in the statement. So this is a binomial distribution, right? And we know that for binomial distribution, mu is equal to n times p, and sigma is equal, or the standard deviation is equal to n times p times q whole square root. Now we are going to use normal approximation to binomial distribution, and that approximation we can use if we have a fairly large set of sample or large sample size. So 25 is pretty large sample size, so we can safely apply normal approximation to binomial distribution. Okay, now we use the values of n and p here to find out the actual value of mu and sigma. So this is the value that we'll get for mu or mean, and sigma 15. Okay, now the probability of observing less than or equal to 211 is represented like this. This is the probability of finding x is less than or equal to 211. So this is what we have to calculate. Now we apply normal approximation to binomial distribution, and in order to do so we will calculate the test statistic or the z statistic, okay, or the z score. We know the formula x minus mu over sigma, and you know that this one is used for continuity correction when we apply normal to binomial distribution. Okay, because normal is a continuous probability distribution and binomial is a discrete one, right? So for continuity correction we have to apply this x bar or the average plus 0.5. Now we calculate it like this, and we get the value of z, which is minus 2.5. Now excuse me, now you have to now you have to use that table. Okay, now using this value of z, we have to go back to the standard normal distribution table and find the probability for this value of z. You can go and check that table and then come back and see what you found. Okay, now if you have seen that already, so from there you will find the value of z, which is the probability for x less than 2.57 is this one, 0.0051, and this is a very small probability. So from here, if the probability of finding the probability of x less than or equal to 211, which means that z less than or equal to 0.257 is equal to 0.0051. If this probability is very small, means that we have very small probability of having this thing, means it is very small probability of finding 211 people in a sample size of 2500 that prefer this brand of the cold drink. So from here we can conclude two things. Either we say that we have observed a very unusual sample that says that it is really equal to 0.10 or the 10%, means that means we have found a sample that is very rare. By very rare means that, or very unusual means that it is very small, the probability is very small. So if there is a probability, if there is something whose probability is very small, we call it rare. It is very rare happening, right? So we have found a sample whose probability is very rare, and it supports the claim of that soft drink manufacturer. Or secondly, we can say that the sample reflects the actual value of P is less than 0.10 or 10%. So the second conclusion we can make that is the percentage is less than 10%, and maybe closer to what is observed in the sample. So what is observed in the sample? In the sample it is observed that 211 out of 2500 have said that they prefer this brand of the cold drink, and if we divide we get 0.08, right? 0.08 means that 8%, right? So we can conclude either of these two things. Either we have found a very rare sample that supports the claim of the soft drink manufacturer, or second is that we have the probability the actual percentage is not 10%, but it is close to 8%, okay, less than what the manufacturer of the soft drink has claimed. Okay, so that's all. If you have any question, you understanding some of the means any of the point here, you can contact me. Thank you very much.